In this video, we're going to review an example using tables within the AdventureWorks database to illustrate the SQL join, how it's written, so its syntax, also how output changes depending on the join type. So with that, we'll dive into the example shown on the screen. We'll start first with the from clause. So this is where the join is explicitly requested. If we start with the from clause at the beginning, we're requesting the query be executed on the address table in the person schema. And then you'll see afterwards, if you haven't seen a join query before, this might be something new. You'll see the letter A, which the letter A is really a table alias. It's not, you don't need the letter A after your first table, for example, in the from clause when you're doing a join. It could be any sort of name that you want to assign to this table alias. It could be ADD, it's shorthand for the address table, etc. So that is the table alias that is essentially used throughout the query in order to refer to which table you're requesting information from. So for example, if we go to the select list, we'll see we have the address ID field prefaced or prefixed with an A and a period, which basically means we're asking for the address ID column in the table with alias A. And so going back into the join syntax in the from clause, we then request a left join. So our address table is our left table, right? Because it's written first before the join is called. And then our state province table is our right table with a column alias, or table alias rather, of B. And so then we also have our on keyword, which tells SQL which fields to use in order to match values as part of the join. So in this particular example, we're going to use values in the field state province ID, which are shared across the two tables as a linking or as the matching criteria for the join. And so every query that uses a join is going to have it appear, that syntax appear in the from clause. You'll have your two tables at least. You'll have your join type. You'll also typically have table aliases because you can use the table name in lieu of the alias, but then you're starting to type a lot of information, right? You'll have person.address.address.id up here in the select list. So that's just to point out that you don't need the table alias necessarily, but most queries in practice that I've ever seen always use a table alias. And then typically with a syntax or a choice of table aliases with letters, A, B, C, D, right? Just because it's easy to use, easy to type, it's more for simplification. Although if you have a really complex query, then maybe you want your table aliases to be more explicit so that you know that which table is actually being used. And then the syntax in the from clause will also have an on keyword that tells SQL again how which values to use. You can use more than one value to match. So you would have an on right A dot state province ID equals B state province ID, and then you would have an and keyword that gives another matching, another two fields across the tables that you would like to match on. So going back to the select list, we talked about the table alias and why this letter is prefixed to our fields that we're requesting. Just to go through this select list in particular, the first three columns or fields are requested from table A, which is the address table, which is our left table in the query. And then the fourth column, the name column, is requested from table alias B, which is our right table, the person.stateProvince table. And so what we're ultimately doing, if you recall looking at the address table, we have a list of addresses with city, state, province ID, and then also postal code. But that state province, what that is, right? If the address were in Alaska, we don't actually see that the state province is Alaska in that data. And so this linking will allow us to supply that name that is located or managed separately in this table, state province. A couple more things on the table alias to cover these bullets. First, you only need a table alias when the field appears in both tables, because let's talk through the state province ID field that appears in both tables here, right? If we don't have the table aliases in front of the column, SQL will encounter something called column ambiguity, or will return an error related to column ambiguity. And that's really related to the fact that SQL doesn't know which column you're referring to because it appears in both tables. So, for example, city, I don't think appears in both tables, so we don't need the table alias. Having said that, in practice, I always am explicit with my table aliases. I like to include them for every field that I'm working with it within a join query, just for simplicity, and then also so that it's clear, even if someone isn't familiar with the tables, which table that information is coming from. And then finally, the asterisk symbol is supported in a join. So if we were to just use an asterisk without a column alias or table alias, rather, all fields from both tables would be returned. We can call all fields from one of the two tables by appending the table alias to the front. So you'll see here an a.star would request all fields from table A. So we're actually going to go now into SQL Server Management Studio and examine this example in more detail, and then also explore how the data changes with different join types. So I'm going to assign my current database, and then we're going to just take a look at the data for a refresher, particularly with the address table, since we've seen this before. We have, right, as I described earlier, address, city, state province ID, and a postal code. We ultimately don't know what the state province ID is associated with, right? And so the information in the state province table will supply that key or that name of that state province. And then there are 19,614 records in the address table. So one question is, why did we want the left join in the table or as part of the query? So when I demonstrated the query, why did I use the left join? Well, we have all these individual addresses, right? And we want to supply another field next to this. And so from my perspective, I'm only interested in this address data. I want to supply the state province. For example, if we need to generate a mailing based on this information, we need the name of the state province, not just the ID. But ultimately, I want all records returned from this table, regardless of whether there's a match in the other table, which means that you would execute that with a left or a right join. We will demonstrate that query that was reviewed in the lecture, or that we just showed in the lecture, can be rewritten as a right join. But the reason that we want one of those is we want all values or all records from one table, regardless if there's a match in the other. And so we'll take now a look at the state province table, since we haven't viewed that in any detail. It's a relatively small table. I'm not going to go through all the different fields because there is more information here. I'm only interested in what is the name associated with state province ID. So recall, we just saw an example with Bothell right at the top, which is one we've seen throughout this course. So that has state province ID of 79. When we look at in the state province table, that's actually associated with a state of Washington in the United States. Notice there are other countries, right? England is a country that appears in here pretty frequently. So just recognize that these aren't all United States names that we're going to be returned here. Names of states, rather. And so there are only, 181 records in this table, state province. Because this table ultimately managed those state province ID codes. There are only 181 of them that are part of this database. It's managed separately from the address table, so that this list can be curated separately, managed separately, etc. But this table has the information that we want. So the good thing to do to start off is test uniqueness of the data, right? I mean, we can do this with looking at the primary keys, but we know already in the address table that state province ID field that we're going to use as the matching criteria is not unique, right? We saw when we pulled back the first 100 records that there were a bunch of records with a state province ID of 79, right? And so if we go down there, there are 2,636 records. But ultimately, what we want to ensure, right, and with the left join, with the address table as our left table, we ultimately want to ensure that what we're joining to is unique. Because if it wasn't unique, we'd be returning more, we'd be duplicating records from the address table. And we do see that in the state province table that field has only unique values. We also can verify that, right, when in the prior lecture I covered primary keys, foreign keys. We can see the address table, the primary key is address ID. The foreign key, a foreign key is state province ID, which means it's a primary key in another table. It happens to be the primary key in the state province table. This is the only field associated with the primary key here, so we do know that it has unique values. So the join, right? What does it actually return? So we're going to return 4 fields, right? The first 3 from the address table, the name field from the state province table. And then ultimately, I know that there are going to be 19,614 records returned, all of which then are displayed with this name field from the other table. And how do I know that? Well, it's a left join, so I know that all of my address records are going to be present. I know that state province ID is a unique field in this table, which means we're not going to duplicate records, which you probably don't want, but you want to ensure that that doesn't happen. So I already know that there are going to be 19,614 records. It's just going to be a quote-unquote new table that's created by joining information across these 2 tables. So when I do that, we have 19,614 rows as expected. We've got our various address IDs. I might actually order by address ID. And because I know this doesn't exist in either table, I will demonstrate, or that it only exists rather in the A table. I will demonstrate that we don't need a table alias here. But just know that that if it were something that existed in both tables, like state province ID, we can generate the error this way. There's an ambiguous column name. Not in this particular example because we didn't request that as well from the request list. And the order by is a little bit different, so I apologize that I didn't catch that immediately. If we were to use this state province ID field in the where clause, for example, we would get an error. The order by was able to execute because it only appeared once in the select list, and recall that you can use column aliases in the order by. So when I run this, we're going to get a ambiguous column name state province ID because it doesn't know which of these 2 fields, even though they're the same, are actually being requested for the ordering or sort criteria. So again, I always like to be explicit with my table aliases so that there's no question what field I'm referring to. So the results are as expected, right? I did want to actually order by address ID so that it matches the original data as returned in the address table, right? And we have the state province name now supplied together with the data. Now, I did start the example with saying, well, you could add, information so that you could generate a mailing or something along those lines. You would obviously need more information returned, but we can simply request that in the select list, right? So how is this working? We'll go into a more specific example just using state province ID of 25. So we'll select only from the address table the first 3 fields that we requested in the join. Note that I use a table alias here in a single table query. You can do that. If I were to remove the table alias A, I would get an error. because it wouldn't know what exactly that A is referring to, because I don't actually supply what that alias represents. So when we run this, we'll get only 9 records. I wanted to work with a smaller scale example. So we have 9 records in the address table with the state province ID of 25. So what does this information look like in the state province table? Well, there's going to be one record, right? We know state province ID only has unique values in this field, or in this table rather, and we will supply that state province ID of 25 and then also the name associated with that. So we have Indiana is our name associated with state province ID. And so state province ID of 25. And so when we match this data up, we're going to end up essentially supplying this information for those 9 records that we returned in the address table. So now we'll have the name Indiana supplied here. We ultimately give it a different column alias. And so to show you that the output is as expected, we see that we have our 9 records, all of which now have the name associated with state province ID of 25 supplied. So that's really what the join, how the left join written in the PowerPoint is working. So let's see what happens when we execute with an inner join, which means with an inner join, the only records that are going to be returned is if there's a match in both tables. So what could potentially happen is that we would lose records from this query relative to the left join, because if for some reason a state province ID that appears in the address table does not appear in the state province table, then that record would not be returned, because remember, an inner join requires that value is represented or found in both tables. In this case, we do get the same outcomes because there is ultimately a match for every value of state province ID in the address table. There is a corresponding match in the state province table, which means the data there in the state province table is ultimately complete. That's not guaranteed when you are working with quote unquote real world data or data that you might encounter in the workplace. When I said why might we want a left join instead, we might ultimately be interested in which values or which addresses don't have a state province ID matched, in which case you still want to mail to all customers, all 19,614 customers, but we need to figure out for those ones where we don't know the state province name, what is that name, why didn't it exist, etc. So ultimately, we have the same number of records returned. So what happens with a full join? In this one, you might be expecting, well, the same number of records will be returned. In actuality, we get more records. So we get 19,721 records, which is, roughly 100 more than what was just returned from the address table. So why are more records returned with the full join? Recall that when we execute an outer join, a full or a left or a right join, that the unmatched records, fields with unmatched records for the joining criteria ultimately have null values, right? So we can ultimately look at the output from the full join and determine where in the first table are there unmatched records. So where in the left table, the address table, are there unmatched records? And so we'll see, we'll return the same output, the same join that we showed above. It's just a full join versus our example in the PowerPoint, which was a left. Then we're introducing a where clause to identify those records where the address ID field is null. So the address from the address table, where ultimately records there were not matched across with the state province table. And so when we do that, we'll notice that we have null values for all fields here. And so there are 107. Those were the 107 that were in excess of the original records from the address table. They're all null values here because those records, essentially the state province ID, was not found in the address table. Now, we don't actually see what that state province ID is, so we can actually add that, right? Because we're requesting it from the table A, and it doesn't exist in table A, so a null value is returned there, but we can request it from the right table, or the state province table with a table alias of B. And we'll see, for example, that some of these, let's just pick one, state province ID of 29. So we can verify that that state province ID does not exist in our address table. So we'll introduce a where clause to return records in the address table with the state province ID of 29, and we'll find that there are none returned. And so that's why the full join returns more records than the left or inner join. And if you think about it, right, this table probably represents complete information regardless of whether you have a customer who actually resides in that state province ID or whatever that data in that table represents. And so that's why it ultimately might exist in the state province table, but not in the address table. And that's also why we wanted a left join. I think in practice, you'll either use a left-right join, probably a left join just because it's easier conceptually, a left join, and also an inner join. It's rare to use a full join unless you're trying to find what's not matched, what is out there that's missing in one table but represented in another. That's just to point out that your left join and your inner join are really what you're going to be working with, but it's important to recognize what does a full join accomplish and why might it be useful. The next query was still with the full join. I was just trying to demonstrate, okay, where does the state province ID exist in the address table, but not in the state province table, which we could, it's not guaranteed that a state province is returned, a state province name is returned. In our original query that we showed in the PowerPoint, remember it's a left join, so if it's not matched in table B, it's still going to appear because it's found in table A. But we know because there was an inner join, right, that an inner join returned the 19,614 records, that those values were ultimately found in both tables across those two tables. So there are no records returned here. It's good to know, though, if we were executing a mailing and needed that field populated, this name field populated, we would ultimately want a query like this to understand, okay, what state province names are we missing? What do we need to populate? What do we need to investigate further? So let's look at what is ultimately output when we introduce a right join on the same query that we saw in the PowerPoint, which was originally a left join, right? So in the right join, we know that the state province table, all records will be represented in the final output, regardless if there's a match in the address table. We might expect that we knew that the state province ID table had 181 records, I think, originally. So we might expect our output to have 181 records. Well, why might it not? Remember that one of the things we tested when we were looking at our left join is whether values for state province ID in the state province table were unique. We know that they're not unique in the address table. So what's going to happen is that records from the address table, records from the state province table are going to be duplicated, or that information is going to be returned multiple times for each time that appears in the address table. But ultimately, every value from the state province table for state province ID is going to be represented in the final output. So when we run this query, we're going to see essentially, we will see, let's just start with the 19,721 rows. Recall that this was the number of rows returned in the full join. So we will ultimately see all 19,614 rows from the address table represented here. What we will not see are the state province name from the full join, if you recall, that didn't have a match, or the state province ID in table B did not have a match in table A. And so this is equivalent to our full join. The reason that it wouldn't have been, or that it might not be at some point in the future, is if this address table also had state province ID fields or values for that field that were not matched in the state province table. So while some of these outputs are returning the same number of rows, right? We had the left join and the inner join return the same number. We had the right join and the full join return the same number of records. That is not by any means always guaranteed, particularly if there are unmatched values in both tables. That's essentially when you're going to start to see differences in the number of records returned from all your different join types. So important to know what you ultimately want from your output and to use the appropriate join type. The last example that I'll show here is, okay, how do we join on more than one table? We essentially introduce another join in the from clause. I'll just go to that first. We introduce another join in the from clause after our original on for the first join. We introduce another join here. We have another table alias, and then we also introduce another on keyword statement that provides the matching criteria to the third table, to table C. Now we could match to table B, right? But recall that we're ultimately interested in the address table first. So it is best practice to join to that table, because if we were to join to table B, it would the join return values would be based on values and records that appear in table B, the state province table, which is more like a lookup table, not really a table full of kind of raw data. And so that might ultimately give us results that we don't want at the end of the day. So important to recognize what tables you're joining on. So we did introduce another table here, the business entity address table. So that's the third table we're going to join to. It does have basically the business entity ID, which is kind of an identifier for what is the business associated with the address in the address table. And so this would provide, I believe this is a foreign key in other tables. So this is going to provide a way to link to additional tables. So you could add a fourth table, a fifth table here to ultimately link more information and bring it into a single table. So we did test in this query uniqueness for the address ID field, which is what we're going to link on here. And it is unique in this table, which means that we're not going to end up getting more than 19,614 records. So that is that's important to test and to recognize before executing a join. And so we'll get 19,614 records, and now we have the business entity ID associated with each address. The last thing I'll say, and why I've been harping on, what happens when you have more records returned than maybe you're not anticipating. The important thing is that some of your information might be duplicated, and so if you were to count, perform an aggregation query across that data or some other summary measurements, you might ultimately replicate values or duplicate values that you did not want to duplicate. So you might double count or potentially even triple count some records when you did not intend to do so at first. So always important to recognize which join type you want, what your join is ultimately going to do if there are non-unique values in one or more of the tables. And then always test for uniqueness. Double check if the number of records returned are not what you expected. Try to find the records that are kind of anomalous or that you weren't anticipating. And it's usually going to be some sort of unmatched value where the value for that field is null. So that concludes this particular video, which really did a deep dive on a query, a join query, and kind of illustrated the way that results change when we change the join types, and then also why they changed, right?